Wrong class. All right, so we've been talking about if statements, Boolean variables, Boolean types, logical operators, and, or, and not. Pretty much think that y'all remember that from fundamentals. That works like this. And means both of them have to be true. If I am hungry and I have money, I'm going to go out to eat. Or means only one or the other has to be true. They can both be true as well. If I am sick or I am tired, I stay home. And then not. Not reverses the truthiness. If I am not sick, go to work. Right? So sick could either be true or false. But if you are not sick, you're going to go to work. That's the same thing as saying if sick equals false, go to work. So to think about that, you can construct what's called a truth table. The truth table looks like this. So for and, both sides of the expression have to be true for the result to be true. For or, only one side of the expression has to be true. And my examples. If hungry and money, go out to eat. If sick or tired, stay home. If not sick, go to work. That kind of thing. And so I didn't list not. Not reverses true to false or false to true. Now in this language, unlike Python, in Python you actually used and, or, and not, but in this language you use two ampersands. For and, you use two vertical bars. That's the shift backslash, not exclamation points. And use an exclamation point for not. So if we were going to word this as C, we would do something like this. If hungry and money, money greater than 0, whatever. So in this case, I guess hungry would be a Boolean variable, a flag set to true or false, and money is an amount. So if you're hungry and money is greater than 0, see out, let's go eat. Let's go out to eat. I haven't already used these examples, right?
No.
Okay, good.
I was just laughing at the money greater than 0.
Yeah. I have 10 cents. I'm going to go out and eat. No, I didn't think you were laughing at me. I was just making sure because I use these examples.
Hey,
all right.
In 1904 context.
That's right. Okay. So if sick or tired, see out, stay home. If not sick, see out, go to work. Go to work, lazy bones. There we go. Actually, that'd be better for tired. Okay. So let's talk about the and truth table and the or truth table. And truth table. Put that in quotes. Where 0 is false. Where'd my 0 go? And 1 is true. So we're going to do X and Y. And what does it equal? Here's our result. So if you have two variables and they only have two states, that's 4 possible. So you have 0, 0, If they're both false, then the result is false, right? You don't have any money, you're not hungry, you're going to stay home. What if you're hungry? What if you're not hungry but you have money? You're still going to stay home. What if you are hungry but you don't have any money? You're still going to stay home. Now you have money and you're hungry, you're going to go out to eat. So for and, both inputs have to be true. So now let's do the or truth table. Again, where 0 is false and 1 is true. So x or y and the result. Again, if you have two variables and they each have two states, you have 4 different combinations. So for or either one or the other, or both, it requires only one side to be true. So or is still off. Now, if I'm not sick and I'm not tired, my result is false. I'm not going to stay home. But if I'm not sick but I am tired, thanks to my very lax job apparently, I'm going to stay home. The result is true. Or if I am sick and not tired, those rare circumstances, I'm going to stay home. Or if I am sick and also tired, I'm going to stay home. So you see how that works. Ands, the only time that and is true is when both the inputs, both of the conditions are true. The only time or is false is when both conditions are false. You just got to remember that. Makes it easy to remember. Another way that might be easy to remember is you can treat and as a logical multiplication. And you can treat or as a logical addition. And I'll show you why. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. Looks like multiplication, right? Because anytime you multiply by 0, the result is 0. Anytime you multiply by false, anytime you and by false, you're going to get a false. But down here with your ors, 0 plus 0 is 0. 0 plus 1 is a 1. 1 plus 0 is 1. 1 plus 1 is 1. What the heck? Well, this is the universe where we only have two values, 0 and not 0. You know, false or true. So if you go on to take a logic class, you will find that people use that notation, multiplication and addition, to indicate things. So, nah, I'm going to skip that. I don't think the book shows it. So here we go. Logical operators. Examples. We have these values. X is 12. Oh, and we got the answers right over here. Let's get rid of those. Okay. So, X is 12, Y is 5, and Z is -4. We just kind of, if we remember that in order, X is the largest, that's smaller, and that's smaller still. Is X greater than Y? Yeah, that's true. Is Y greater than Z? Yep, that's true. So we have true and true. So what is the result? True. Yeah, that's true over here where I hit it. How about X greater than Y? That's still true. And Z greater than Y. Is Z greater than Y? Nope. And requires one or both sides to be true. Both. So true and false. The answer is going to be false. How about X is less than or equal to Z? Well, obviously if X... Well, let's check it out. Is X less than Z? No. So this is false right there. But it's an or, so we need to keep checking. X is equal to Z. Well, that's still false. So the whole thing is false. Both of them are false. How about X is less than or equal to Z? We decided that that's not true. Is Y not equal to Z? Is that true or false? True. That's true, actually, because Y is not equal to Z. And so with an or, only one side has to be true. So the answer to that one is true. And then lastly, not. Not reverses the truthiness of whatever comes after it. So is x greater than z? Is that true, that x is greater than z?
Yes.
That's true. So not turns it into a false. Now, honestly, nots make things harder to read, in my opinion. If I was going to express that logic, I would instead write it like this. It means the same thing. I would rather see if x is less than z rather than if x not greater than or equal to z. Logically, they're the exact same, and the computer doesn't care. But it kind of hurts my brain to look at that and figure out what it's doing. The clearer the code you can write, the better. And I think I've already mentioned that the opposite of less than is not greater than, it's greater than or equal. The opposite of greater than is less than or equal. And the opposite of equal is not equal. Why do I say that? Because if you wanted to write not A greater than or equal to B, if you wanted to rewrite it so that it gave you the same answer, you would say A less than B. If you wanted to say not B greater than 10, then to express it without that not in front of it, what is the opposite of less than? It's greater than or equal to. So you would say B is greater than or equal to 10. These are both the same, right there. These are both the same. What would matter? What would happen if I'd left that off? Well, they would behave differently.
Since if B were equal to 10, neither would.
Right, because if B equaled 10, then that's wrong. It would be false there, but it would be true there. Because is 10 less than 10? No, but this would turn it to a true. Is 10 greater than 10? No, that's a false. And I was trying to write something where they, express the same thing. So you just have to remember that. Alrighty. So are we employed and we're a recent grad? We qualify for the special interest rate. I have like 3 books that use the same example. They're stealing from each other. Else you must be employed and have graduated from college. So this both has to be true. You have to be employed and you have to be a recent grad. How about if your income is greater than the minimum income and your years are greater than the minimum years, you qualify. Except they used or. So if you have enough income, they don't care about how many years. If you have enough years, they don't care about your minimum income. And so if both of those are true, if either one of those is true, we qualify. Otherwise, it prints out an error message. There's something called De Morgan's Law. Let me do a search and see if they talk about it. Nah. Okay, I'm going to mention this, but it's not going to show up on an exam. If you need to reverse an expression that has an and or an or, rather than just like greater than or less than, like if you do this. Their example was, if you're a recent grad, and recent college, then you get the discount rate. That's expressing it more like Python, but just roll with me. Then print, okay. See out, you qualify. Else, see out, you don't qualify. What if you wanted to reverse it so that it would print out you qualify first? What if you wanted this to be the else and you wanted that to be the if? So you might be tempted to say if grad not equals yes and college not equals yes, but that wouldn't work because that would not handle the case where grad is equal to yes but college is equal to no. So if you wanted to do it like that, you'd have to do this. If not, grad equal to yes and college equal to yes, that would be one way of doing it. See out, you don't qualify. else you say you qualify. But then you remember Professor Thompson's advice to get rid of nots if at all possible. Now, De Morgan's law is a Boolean math law that says if you're going to swap something and you're trying to move the not and trying to distribute it into the inside, then you have to also reverse these. And you reverse that. So here's how you would word it. You could take this expression and you could rewrite it as this. If grad not equal to yes, or college not equal to yes, then you could see out your message. You don't qualify. And I like this expression better, right? I don't have to figure out, oh, and by the way, since this is C, we would have to put parentheses around the whole thing, which would make it even harder to read, right? We'd have to put parentheses there, and parentheses there. But ignoring that, these do logically the same thing, but I think the second one is easier to read. You're either, if you're not a college grad, or somewhere I messed up. I've been using grad in college the whole way through, and I meant to say employed in college the whole way through. Yeah, hope that was clear enough. Sorry about that. I'm replacing every instance of the word grad with employed. Hope the little example still made sense based on what I was saying. That makes sense, guys? Am I going to ask you to remember De Morgan's law? No. But using De Morgan's law, you can eliminate the not by reversing the comparisons, changing equals to not equals, or changing less than into greater than or equal, and reversing the logical operator. You can change and to or to and. I'm going to replace that word and with our C version. I'm going to go ahead and put parentheses around that. All right, that looks a lot more like C, except for missing semicolons and stuff. So logical operator notes, just like math, multiplication has a higher precedence, has a higher priority than addition. Well, logical operators are the same. And we said up here that and is the logical equivalent to multiplication. And we said that or is a logical equivalent to addition. So if you just had to take a guess without looking at the slide, which one's going to have higher precedence? The one that's logical multiplication or the ones that's logical addition?
Logical multiplication.
Yeah, so and has higher precedence than or. Meaning you need to be careful about how you write your stuff. Trying to think of an example. Okay, I'm not going to come up with a good example yet. If you have three Boolean variables, whatever those are, which one gets done first? Yeah, that one gets done first. So that is the same as that, with parentheses around that part. That has to get done first, just like multiplication. But what if you have A or B and C? Which part are you going to do first? The A or B? No. Now that's logical multiplication there. That has to happen first. Then we have logical addition. So that is the same as A or B and C. I recommend using parentheses with reckless abandon to make it easier to read. You know. Yeah, I know, since I'm the supreme programmer, that A and B or C solves in the order that I want it to. But I'm going to add parentheses anyways, because I want it to be clear. And if I expected this to work from left to right, then I'm going to be messed up. My program's not going to work the way that I wanted it to. So why didn't I just use the parentheses in the first place so that I don't have to worry about precedence? That's my recommendation. Use parentheses to force the order of operation so you don't have to worry about precedence. That's the prof's recommendation. So if you had this, W, X, and W ORed with Y. And then I was going to put parentheses around it the way it was actually evaluated. Which gets evaluated first? Right, the AND gets validated first, so it's going to look like this. W or X and Y, or X and W or Y. That's how it's actually evaluated. Since that's actually how it's evaluated, I would go ahead, if I was going to write this, and code it like that and not just trust it. Looking at this, if you just walked up to this code and looked at it and didn't remember your order of precedence, you'd probably think that would happen, and then that would happen, and then it would be ANDed. You might not. Now that you've taken the class, you wouldn't. But if you wanted it to behave that way, you'd have to put parentheses there and there and there and there, if that was your intention. Just like with addition and multiplication. Now they talk about short circuit evaluation. Short circuiting sounds bad. Captain, the engines have short circuited. Instead, it's actually a good thing in many ways. If you have this expression, if, hunger greater than 0 and money greater than 0. And has to be true, right? They both have to be true. So if hunger is not greater than 0, does it even have to check money? Well, they both have to be true for it to work. So can we skip checking money if we know that we're not hungry? Somebody say yeah. Yep. Okay. So short-circuiting means that if you're doing AND, if the first part evaluates to false, then it skips the rest of the expression. So short-circuiting AND. If the first expression is false, the second one is not evaluated. And that's kind of good news, because if you have a while loop and it's going to run 1 billion times, then you want to put the one that's less often true in front. Right? Because doing this comparison actually does take a little bit of time. The chip has to do some work in order to do that comparison. So if you're hungry only 10% of the time, but you have money 90% of the time, if you swap those checks, it would have to do the other side 90% of the time. But by putting the one that's less often true in the front, then you would only have to check the second one 10% of the time, and you could write faster code. Short-circuiting for OR works a little bit different. If sick or tired. If we can establish that you're sick, do we even have to check to see if you're tired? Did I hear a no?
If you're sick, yeah, don't check.
Right, if you're sick, you don't have to check to see if you're tired. because this is an or, and only one side is required to be true. And when I say you don't have to check, I mean the computer doesn't check. The languages are written in such a way that if the first part of the expression is false and you're using or, it does check the second one because they both have to be true. But if you're doing and, if the first part of the expression is false, it won't check the second one. So, short-circuiting for or. If the first expression is true, the second one is not evaluated.
And that can be more than two.
Right, if you have a whole bunch of them chained together, if x is greater than 10 and y is greater than 1 and, you know, z is less than 3, whatever, they all three have to be true for this whole thing to evaluate to true. So if that's false, it's going to skip the rest. Only when that one is true is it going to move on to the next one. And then, oh, well, that one's false, so I'm going to skip the next. They're doing that for performance reasons. There are some side effects, though. If z is a function rather than a variable, and you're expecting z to be called every single time this if statement is executed, that's not going to happen. Z is only going to be invoked every time both of these other ones are true. Go back. Hey. Get a clue. All right. Checking numeric ranges with logical operators. What if you want to check to see, and I know we've done this, if something is within a range? We want to see if the water is a liquid or not liquid, if it's ice or boiling. You could do this. Say we have a temperature, whatever the temperature is. I shouldn't be making, I'll type this. But if temperature is less than 32, no, I'm going to change it. If the temperature is greater than or equal to 32, and the temperature is less than 212, because those are our limits for the Fahrenheit system at sea level, at 1 standard atmosphere pressure, then we would say liquid. Else, we would say that it's not a liquid. But what if you wanted to exclude it? What if you wanted to check the ends of it? What if you wanted to make sure that you were checking outside of the range? So here's our general rule. When checking a range, use and I hate repeating the word and. Use and. Okay. I mean, why not? We use longs, but use and, comma, less than or equal to, comma, and greater than or equal to. Those are how you should express the limits, like that. The lower boundary is 32, the upper boundary is 212, so we used and we use those things to check it. How about when checking outside the range? What if we want to prove that it's not a liquid? You do the opposite. What's the opposite of and? Or. What's the opposite of greater than or equal to? If I scroll back my notes, what would I say the opposite of greater than or equal to is?
Less than.
Less. Yeah. And then the opposite of less than or equal to is greater than. Oh, come on. There. All right. So if the temperature is less than 32 or the temperature is greater than 212, then you could see out not a liquid. Like that. So when checking within a range, we use and those two. When checking with outside of a range, you use that. Okay, now I'm going to show you a sneaky way of doing it if you didn't want to remember that. Right, if this is just the opposite of that, you could use the not operator. You could take this, and I'm going to delete it as soon as I do. And you could say, if not that, then see out not a liquid. Which one looks better to you? That one or that one?
That first one.
I like the first one. It's easier for my brain to comprehend. And if it's easier for my brain to comprehend and Daniel's brain to comprehend, then it's probably easier for you when you look at the code as a newcomer to it. The faster somebody can read your code and understand what it's doing, the more likely they are to not make a dumb change to it. So I'm just going to delete that. So that's how to check within a range, and that's how to check outside of a range. So here we go. We're going to check to see if a value falls within a range. Now in this land, you can't score greater than 100. So you also can't score less than a 0. Thank goodness. So if your grade is greater than or equal to 100, and your grade is less than or excuse me, I said that wrong. Grade greater than or equal to 0, and your grade is less than or equal to 100, you're going to say it's a valid grade. They didn't make a mistake typing it in. But what if we want to check to see if it's an invalid grade? They goofed. They didn't follow our rules. This is going to tell you that your grade is invalid if you made 100. I would get annoyed if I made 100 and it told me my grade was invalid. Shame on the book. I demand a refund. Okay, this is accurate. If your grade is less than 0 or your grade is greater than 100, print out invalid grade. Now you can't write it like we did in junior high or whenever we did it and express it like this. This is perfect math notation, but it's not programming notation. You couldn't do it in Python. You can't do it in this or Java or anything else. Why? Because these are binary operators. So first it would evaluate, binary means it has 2 parts, right? So it would evaluate this expression, is 0 less than your grade? And it might say that that's false. So then it says, is false less than 100? That does not make a lick of sense.
It can't be compared.
Right, you cannot compare it because this turns into a logical, and you can't compare a Boolean value with an integer. Menus. A menu-driven program. That's when you give a user a list of choices and a chance to input something, and you do something based on that input. Did we do the sphere program where you say the density is this and that and the other?
Yes.
Okay. So, you know the size of the sphere, and then if the sphere is gold, so that's a yes. Okay, we've done that, and not just in my fundamentals class that half y'all took. Okay, so you display a list of numbered or lettered choices for actions. You prompt the user to make a selection. You test the user selection and expression. Now, we actually did this with our phone digit thing, right? If they typed in an A, you press 2. If they typed in a B, you press 2. If you typed in a C, you press 2. That was a menu-based program, except we didn't display the menu. We didn't say press any letter A through Z. That would be a proper menu. And even more realistically is if it said press A for this, press B for that, press C for that, you know. Let's see what example they give, because I always come up with that gas one, that sphere one. Validating user input. Now they sure do give this short shrift. Like what? We're only going to have one slide based on menus? That's pretty lame. Validating user input is the idea of making sure that they typed in good input. Now, the idea of typing in good input is not being handled adequately in this chapter. What do I mean by that? You know, if you type in a letter rather than a number, then your program goes nuts. And we have no idea yet how to solve that. So, it's not that kind of user input we're validating. And instead, it's if they make an invalid choice. Press A to add somebody to the database. Press D to delete them from the database, something like that. Let's do an itty-bitty little menu-based program, but it's going to do a little bit of math rather than anything else. So I should always start Visual Studio before I come in. I mean, before I start the lecture. But anyways, crank up a new program. Get your boilerplate ready. Empty project. I should take the time to make my project name today's date so it'd be easy to find. Since I'm not uploading mine, I don't do that. Now I need my Solution Explorer, so I'm going to view the Solution Explorer. Here he is. Source files, right click. I know everybody knows how to do this, so I should just shut up, but I can't help myself. I'm going to make a CPP file. What do you use header files for? You put prototypes in your header file. That's what you use header files for. And then later when we start creating classes, we're going to use header files for classes. Alrighty. So include IOString, include string using namespace std, int main, system buzz. There's all our usual goodies. Now I'm going to go ahead and structure this as a loop to begin with, rather than go to the end and then say, oh, we should have made it a loop. So what we're going to do is let's create a variable that's going to hold our input, string, you know, and let's give it a good name, choice. And let's give ourselves a starting number. But I'm going to make it a float or a double so that it can, you know, go down to, you know, fractional parts. And I'm going to call it value. I'm going to start it off at 1. I'm going to give choice a value so that when I do an if or a while based on it, it doesn't blow up and say it was an uninitialized variable. So I'm going back to my string choice, and I'm going to say string choice is equal to, you know, empty quotes like that. Except I typed 2 equal signs for some reason. Had a little brain glitch there. Should be 1 equal. So string choice, single equal sign, empty string. So now my thing is going to be while choice is not equal to Q for quit. Let's ask them for a choice. We need to come up with a cute little menu. What I'm thinking is adding, multiplying, and dividing, and, you know, subtraction. So let's put some couts. A to add to, \n. The next line of our menu is going to be S to subtract to, \n. And then M to multiply. So cout arrow arrow M to multiply 2, or multiply by 2. It's funny how we use the word by for adding but not subtracting. I mean, for multiply but not add or subtract. And then cout D to divide by 2. And let's also tell them that they could quit. Q to quit. So we need one more cout. Now we're going to do a little menu. And we're going to check their choices. If it's A, we're going to add it. If it's S, we're going to, you know, subtract, multiply, and divide, and stuff like that. So if choice is equal to A, let's do a little block of code. Value plus equals 2. And then do the same for S and M and D. S is going to be minus equals 2. M is going to be times equals 2. And divide is going to be, divide equal 2. So, else if choice is equal to subtract, and you could have done this without watching me type it, just based on what I said, value minus equals 2. Else if choice is equal to M, not N, M. Value times equals 2. Else if the choice is equal to D, we're going to divide by 2. Else if choice equal D, value divide equal 2. And we gave them one more choice, which is quit. So let's include that in our menu. Else if choice equals Q, let's just say okay. C out, okay, /N. But if none of these are right, we need to tell them that they chose some bad input. Now I'm going to do something to my code that I wouldn't necessarily recommend to you, which is I'm going to take the braces out. And the only reason I'm doing this is so that I can get more of the code on my screen at the same time, right? You leave your braces in. There you go. And so if none of that stuff is true, if it's not one of our menu choices, we need to tell the user that. Else, curly brace, C out, invalid choice, \n. And again, I'm going to remove those braces, and I'd recommend you don't. So we had the beginning of a while loop up here. Remember that? I need to make sure that I have the end of the loop here. I do. But I'm going to put a little comment here, just like our pseudocode from fundamentals. That's an end of while, and this is an end of main. And it's gone nuts. I must have done something wrong. Oh, this is cute. What did I do wrong? I bet somebody can spot it real fast.
You never asked her.
I never ask. I display the menu, but I never get it in. So after this CL, after all this C out of our menu, but before the first diff, I need to use CIN and read it into result. So scroll back up to your first if statement, and above that, not result, excuse me, our word was choice. And do CIN arrow choice. All right, there's our little menu. I'm going to add to. It's not printing the result. This is kind of boring. So where should we stick the place where we print the result? Should we print it down here at the bottom? Should we print it up here before we display the menu? Effectively, they're the same thing. Let's do it up here. Let's do it right under the while loop. C out, current value is, end quote, arrow, arrow, the value, arrow, arrow, ENDL. So just stick that up there underneath the while, above all the other C outs. And then run it again. Why did we do that? Because we weren't seeing, we were multiplying and dividing, but we never saw the result, and that was boring. Okay, so the current value is 1. I'm going to add 2 to it. The current value is 3. I'm going to multiply. It changed to 6. I'm going to add to it again. It's 8. This is kind of boring because it's always even numbers. We could make it more interesting and ask what to multiply by, and stuff like that. And then so divided by 2 and it becomes 4. Divided by 2 it becomes 2. Ah, you're right. If we divide it once more, we get an odd number. Good thinking. And then I'm going to start adding to it. 3, 5, 7, 9. Now I'm going to divide it by 2 again, and I'm going to get a fractional number. I did something wrong. Invalid choice. D.
You typed in 2.
Yeah, I typed in 2. That was dumb. All right, there we go. All right, so I divided it by 2 a zillion times. Now I'm going to start multiplying it. Check it out. Well, that's actually not what I meant to do. I'm starting to get rounding errors now. I've mentioned rounding errors before, although I wasn't able to prove that it happens. That's a risk of using floating point types. All right, anybody have any syntax errors you need help with? Please get me over there. All right, just a sec. We have now illustrated menu base. We have illustrated looping. Notice that I didn't do that priming read that a lot of textbooks show, which is where you ask the user what you want to do and then you go into the while loop. Instead, I just initialize a variable to an invalid choice and I ask them inside here. Because otherwise, and don't make this choice that I'm about to do, if I hadn't done it like that, I would have to have structured it like this. I would have had to display the menu, I would have had to read the choice, and then I would have my while loop, which did all the same thing. Don't like that. I despise that way of doing it. So I try to avoid priming reads as often as possible. And you probably remember the term priming read from fundamentals, even if we haven't talked about it in here. So, for validating user input, there are tests you can check. Is the data within a possible range? Like if you're going to ask somebody for their age, don't let them type in a negative number. Don't let them type in a value greater than 150 or whatever you expect the maximum lifespan to be. Reasonableness. I don't know about that. But I guess if you're asking them to enter a first name, you don't let them enter a first name that only has 1 character in it. I'm not sure if that's a universal law though, right? Because what if they're typing in their, their name in Korean and a single symbol is valid? So that would not be a reasonable thing to inflict on them. A valid menu choice, that's what we did. And at all costs, we want to divide by divide by 0. See if we could check to make sure that we were not dividing by 0. Comparing characters and strings. Characters are compared using their ASCII values. So if you compare 2 strings to each other, the A's are going to be before the B's, which is great, right? For sorting all your songs, you want all of your artists A with the name of A to be less than the name of B. You want ABBA to show up before the Beatles, or whatever. And there's a consequence, though, that lowercase letters have a greater ASCII code than uppercase letters. So if you were going to sort these values, Cher, Beatles, ABBA, and let's just try to throw in one. My brain is Cuckoo. That's the name of a new band. Alrighty. And then we told it to sort. It would sort it like this. Well, C is not the smallest ASCII value. B is. We could check our ASCII chart and find out that a B is a 66 ASCII value. So it would put Beatles up at the top. Then it would look for the next lowest ASCII value, which is a C. So it put that there. And then it finds the next lowest ASCII value. And you might not believe it, but we could look at the ASCII chart and prove it. All the lowercase letters have higher values than the uppercase letters. So then it's going to put ABBA down here, and then it's going to put Cuckoo down there. And if you looked at your song list, your artist list, and it looked like that, you'd probably get annoyed. Why are all the uppercase names sorted to the top? Why are all the lowercase names sorted down at the bottom? If you forgot to capitalize Pink Floyd, and you had Pink Floyd in all 3 cases, let's figure out where they would go. Well, Pink Floyd should be after Cher, that's good, but we have a lowercase letter there. Uppercase letters are there. Uppercase letters are considered smaller, so it would look like, whoopsie, look like that. And then we have all, okay, I goofed. And then we have all lowercase letters. So when you were looking at your artist list, it would look like that. And you'd be really annoyed at your phone's music player or whatever if it was showing, 3 copies of Pink Floyd just because one was uppercase and one was not. So when people invent algorithms for sorting names and stuff like that, they take that into account. One thing you could do is just convert everything to uppercase, at least for your sorting purpose, right? Don't display it all in uppercase, but at least convert it to uppercase when you're sorting it. So when you're comparing letters, you don't just have to do if choice is equal to D. You could also do if choice is, I don't know, greater than C. I don't know why you would do this. And choice is less than E. Right? So if you were checking for D, these both would check and find the same thing. Now, I would think that the second way is moronic, and the first way looks a lot better to me. Just be aware that if you're comparing strings, they're equal only if they're all of the same case. Otherwise, uppercase letters have a higher, smaller value than lowercase letters, which is kind of the opposite of what you might think. If we go and look at the ASCII chart, don't make it hard for me to find one. Which for Pete's sake, forget it. Just, okay, I'm going to go back up and get one that I'm pretty sure is good. One of the ones I've used in the past. There's something I didn't like about this one, but I'm going to go with it this time because I couldn't find another one that worked. It's because this one's blurry. Forget it, though. Uppercase A is right here. Lowercase a is here. Uppercase A is a 65. Lowercase a is a 72, something like that. So lowercase letters have greater values than uppercase letters. If you're checking strings, like I mentioned, you can use greater than, you can use less than, or you can use not equal than. Is name 1 less than Mary Jane? We'd have to look it up. Well, name 1 is Mary. However, this name is longer than Mary. So we'll go, okay, Mary, I've matched that far. All right, well, but this isn't right because this has got some extra stuff on the end. So I'm not going to consider them to be equal. I'm going to consider that the shorter string, if they match up to a certain point, is less than the longer string. So if our code looked like this, if name is equal to Bob, N1 is equal to Bob, N2 is equal to Bobby, N1 is less than N2. That's just a fact. If N1 is equal to Bobby and N2 is equal to Bob, then if you're comparing the strings, N1 is greater than N2. Because it checks, and it checks, but once it hits the end of it, the longer one wins. The longer one is considered larger. The conditional operator, and this one's a weird little beast. You did not have this in Python. It exists in Java and stuff like that. But here's the way it works. Say x is equal to 100. And say you have a variable called name. So we write it like this. Name is equal to x greater than 50 question mark. If that's true, then the name is big, else the name is small. Let's not use x, that's kind of stupid. Age. Age is equal to 65. If the age is greater than 100, we're going to say really old. Else, we're going to say pretty young. So if you're 99, you're pretty young. Again, this is a silly example, but the way it works is this comparison is done. If this is true, this string gets copied into here. Else, this string gets copied in here. Now that's the way that it works in Java and in C++, but C++ gives you some weird, more perverse ways of using it, which are things like this. You can write x equals 0 question mark b++ colon C++. What that means is this true? If this is true, do that. Otherwise, do that. I don't think that's too cool. Now this code right here is the exact same as if we wrote this. If x is greater than 100, then name is equal to really old, else name is equal to pretty young. Those do the same thing logically. There's no difference between writing it like this and writing it like this. Again, it comes down to a matter of style. Which do you like better? I like that for most purposes. The parentheses are not necessary here, but I like putting them because it makes it jump out at me, right? The syntax to me is clearer if the parentheses are there. And this thing down here, if I wanted to rewrite it, I would do if x is equal to 0, then b++, else C++. Again, these two things mean the exact same thing. Again, which one do you like writing more? It's up to you. I think that's easier to read. But, you know, if you've been programming for, 5 years and you feel like you don't want to waste 4 lines where 1 line would do, feel free to do it like that. That's called the conditional operator. So the conditional operator is a question mark. Some people call it the ternary operator because it's the only operator that has 3 parts, right? We have a lot of binary operators that take 2 parts. This is the only one that takes 3. So the way it works is there's a condition followed by a question mark, and then there's a value 1 followed by a colon and a value 2. If the condition is true, the result is value 1. If the condition is false, the result is value 2. So, state is equal to temperature less than or equal to 32, and the temperature is greater than or equal, no wait, I went the wrong way with that. Greater than 32, less than 212, colon or question mark, and if that's true, we're going to say liquid, else not liquid. That does in one statement what we were doing with an if, if else earlier. And again, these parentheses are not necessary, but I think it sure helps to read it, right? If you're looking at that, that's just kind of, what? Okay, so there we go. I'm not going to even write that in the form of an if-else. You get the idea. If that's true, then it evaluates to this, and that's copied into state. If this is not true, then the second is copied into the state. Alrighty, I'm real interested to see if we have any homework creeping up on us. How many assignments are we ahead, if any? of our current date. So we're on the cell phone, which I never gave a date. That was dumb. I'll make it do a date a week from today.
Yeah.
I never like to make anything do less than a week, so even though you've probably already finished it already. Alrighty. And we don't have anything after that, so we need something else. I didn't have anything else planned. We jumped straight from the switch statement to loops. I guess that's okay then. We'll hit chapter 5 next week. We'll start talking about loops. We'll have a good time with that. We haven't had enough homework though. Wait a minute. Did I not say that I wanted a homework assignment where we finish that?
Cell phone?
But there's no Dropbox for it.
Yeah,
Smart.
that's what you're doing just now.
Alright. So it's going to be homework assignment 6. Finish the cell phone program. Apparently I forgot to upload that.
Put the assignment in.
Yeah. And that's what's due next week. And we did the sphere, so we've already been introduced to menu-based programs. So I'm okay with where we are. Let's make a Dropbox for where we are today. I'll need to copy the instructions, so this will be J. Alright, it's there. If you scroll down, you'll see J, the menu-based program. Go ahead and finish the cell phone program. I should have cooked up another menu-based program in my head, but usually I slot the sphere one in as that, and I made y'all do it too early. Alright. So are there any questions? Or if you need to hang out and work on homework, you know, I have 15 minutes before my next class, we can do that. Oh, let's see if we got a quiz cranking up for chapter 4. Well, yeah, it's always available, but it's time to go ahead and make it do. Alright, so try to get the quiz done in a week. Then I'll grade it, and you can retake it.